All right, so today we're going to talk about special right triangles. There's two types of special right triangles, and it all has to deal with the angles that are inside of the right triangle. So we all know that right triangles have 90-degree angles in them, but there's one case where the other two angles are 30 and 60 degrees. So that's known as the 30, 60, 90 triangle. Okay, and so when we're looking at a triangle like this, there's something that happens with the sides every single time. They're always related to each other in this way. So I have it labeled that the side across from the 30 degrees is known as S. And I use S instead of using like X or Y because sometimes they'll put X and Y on the triangle as the measurements that you're trying to find. And so I'm using S. And you could also refer to that as like the shorter leg because in a 30, 60, 90 triangle, one of the sides is going to be smaller than the other one. So the side across from the 30 is going to be the shorter side. So I use S to kind of represent that. Now the side across from 60, that would be the longer side. That's using S square root of 3. And the side across from the right angle, the hypotenuse, is your 2S. Okay, so I kind of use those, like I said, those letters instead of using an X or a Y because X and Y get used a lot in math anyway. So these just kind of differentiate that a little bit for you. But you could refer to this side, like I said, as this is the shorter leg. This is the longer leg. And this is still the hypotenuse. So if you'd rather label it like that, you can. So when you guys are doing a problem with a 30, 60, 90 triangle, the first thing, like usual, is figure out where the hypotenuse is. And then label it. And I would, if you want to, either do your short leg, long leg, or use your S, S radical 3, 2S. So let's look at some examples here. So they want us to solve for anything that's missing on the triangle. And like I said, for these ones, they're going to start throwing in X's and Y's to represent the sides that are missing. Okay, so X is on the side of the hypotenuse. Which is equal to 2 times my S value. The Y is across from 60 degrees, so that's the longer leg. And so that's equal to that S radical 3. And then 30 degrees across from that is the 21. That's the short leg. And that's equal to your S. Okay? So in short over here, X is going to be equal to whatever S is times 2. And Y is going to be equal to whatever S is attached to a square root of 3. Now, across from 30 is that 21, and that's my S value. So for this one, we didn't have to do a lot of work to find S because they gave me the number right away in the problem. So I'm going to go ahead and be able to say that my S is equal to 21. So then up here to find X and find Y, I just plug in that S. So to find X, I'm going to take 2 times 21. So that would be 42. So there's your X. And then for Y, I'm just going to put 21 in the place of S. So 21, and then you have square root of 3 attached to it. And I'm not going to do anything further here. I'm just going to go ahead and leave it like that. So depending on what side they give you, because they might give you the measurement for the side across from the hypotenuse, or I'm sorry, across the right angle, or they might give it to you across from the 60-degree angle. It might change then how you solve the problem. So let's take a look at another one. So this one, across from 30 degrees, that's where they have X. So that's going to be my S side. Across from 60 degrees, that's the longer leg, that's that 12. So that's my S square root of 3 side. And then across from my 90 degrees, that's where the Y is at, that's the hypotenuse. So that would be my 2S. Okay, on this one, they did not give me the S value right away. because I have x is whatever s comes out to be, and then for y I have to take 2 times my s value. The only side that they give me a measurement for is that 12. Okay, and I said that that side is the s square root of 3 side. So, like on the last problem, let's come back up here, they gave me the 21, and I said that that was equal to s, so I was able to say s equal 21 right away. In this case, I'm going to have to say that s radical 3 equals the 12, and then we're going to have to solve for my s. So s square root of 3 equals 12. And we have to solve for s here. How do you guys think we're going to do that? How do we get s alone? Good. Divide by that radical, because right now it's s times the square root of 3. So I'm going to divide by the square root of 3 on both sides, like that. Now on the left side, those square roots are going to go away. Okay, the square root of 3 over the square root of 3, that becomes a 1. So I'm left with s. But you probably were taught, that you can't have a radical in the denominator. It's considered bad form. So we have to get rid of it by rationalizing it. So to get rid of it, we're going to multiply the top and the bottom by that square root of 3. So now I have s equals, and if I multiply these fractions here, on top I have 12 square root of 3. And then on the bottom, if I have square root of 3 times square root of 3, that would be the square root of 9. What is the square root of 9? 3. So anytime you guys take a square root times itself, the number is going to end up just coming out because it's going to be the square root of that number squared. So they basically cancel each other out. Can I reduce the 12 and the 3 on the bottom? Yeah, what would it reduce to? Good, 4 square root of 3. So that's my s value. So coming back up here, where I had to find x and y, we said that x was equal to the s value, so x is equal to that 4 square root of 3. And for y, we have to take 2 times the s value, so 2 times the 4 square root of 3. And when you're multiplying a problem like that, you can only multiply the numbers that are alike. So you can only multiply the 2 and the 4. You can't take 2 times the 3 because it's underneath the square root sign. So this says 8 square root of 3. I would say this situation is like the hardest one when it comes to a 30, 60, 90 right triangle. Because that s radical 3 side, if you have to set it equal to a number, you have to do a little bit more work with it. So you have to do all of this in order to solve for your s. The other cases, like the first one I gave you, that one's probably the easiest because they give you s right out. And then if they give you the hypotenuse instead, you just have to divide by 2 because it'd be that 2s side. So it's a little bit simpler math. It's not as complicated as this one would be. This is the hardest case that you're going to see on a 30, 60, 90 triangle. I want you guys to try this one on the bottom of that page in your packet there. It's still a 30, 60, 90 triangle. So label it and then find x and y. Okay, so for this one, I labeled my sides. Now that top angle in the corner there, that's the 30 degrees. So across from that, where the x is at, that's my s. Across from the 60, that's where y is. That's your s radical 3. And then the 10 is your hypotenuse, the 2s. Okay, so this is the side that they give me. The only side that I have a number on is that 10. So we're going to set 2s equal to your 10. How do we solve for s? Divide by 2. So we get s equals 5. Okay, so now that I have s, I go back to my x and to my y and I plug them in. So for x, that's just your s value, so that's just going to be 5. So x equals 5. And then for the y, it's 5 radical 3, because you're just going to attach those two pieces. And that's your answer for that one. Okay, so let's talk about the other special right triangle now. So this is the 45, 45, 90 triangle. This is technically an isosceles right triangle, because when you have those acute angles being the same measurement, so the 45 and 45, the sides across from the 45-degree angles also are going to be the same measurement. Okay, so when you guys were in geometry and you talked about the different types of triangles, isosceles are the type where you have two that are the same length and one's different. So in this case, the sides across from 45, I'm using the letters L to represent them, and they're going to be the same. So sometimes on a triangle you might see those lines through the sides. If they have the same number of dashes through their sides, that's just telling you that those are congruent to each other or equal in their length. And then my hypotenuse is the L radical 2. So it's a little bit different in how we label it than our 30, 60, 90 triangles. We're going to do the same type of problems here. We're going to be solving for missing sides, and I would label these triangles like we did before. So this one, we're moving on to the 45, 45, 90 here. So those sides across from the 45 degrees, which would be those two corner angles, those are going to be the same. So they're both going to be your L value. And then the side across from the hypotenuse, or the 90-degree angle, is the hypotenuse. That's where my x is at here. This is going to be my L square root of 2. What is L equal to for this problem? 9, because right here they give me the side of the 45, 45, 90 triangle is 9. So that means that your L is equal to 9. So x is just going to be that L value, so the 9, times the square root of 2, because I just plug it into there. That's my answer. Okay, again, this is probably the simplest case you're going to see when it comes to a 45, 45, 90. If they give you one of those sides right away, you just have to plug it in. Now, number 2, they're still giving us those sides. It just isn't a plain number like 9 was. This time, those two sides that are across from the 45, 45, those are 6 square root of 2. So this is my new L value. And that hypotenuse side is going to be that L square root of 2 value. So they are giving us L still, like right away, because it's the 6 square root of 2. But in order to use that, we have to take it and plug it into L squared of 2. So this whole piece, the 6 square root of 2, that's going to go in just for the L piece. It doesn't take place of the square root of 2. So you're almost going to have 2 square root of 2's right next to each other in this problem. So 6 radical 2 times radical 2. Don't forget to include the second one, because I see students want to drop it, and then they just leave it at 6 radical 2. Now to simplify this, remember on like an example on the previous one, I said you can only multiply things that are like each other. Well, I have these radicals that are alike. So what would be the square root of 2 times the square root of 2? What number would be underneath the square root sign now? 4. 4, because 2 times 2 is 4. What's the square root of 4? 2. So to finish this, we're going to take 6 times 2, which is 12. Okay, on the bottom there's 3 and 4. I want you guys to try them. See if you can figure them out. All right, if we take a look at number 3, If I label my sides where the x's are at, those are the sides that are the same measure, so those have to be my L values, which means that the 5 radical 2 side has to be my L square root of 2. Okay, notice here how they both already have the square root of 2's. Okay, so that means that the L and the 5 have to be equal to each other. And it works the same way if you were to actually set it up like this, where you set them equal to each other. If you're solving for L, you're dividing by that square root of 2 on both sides, and it causes them to cancel on both sides. So that's how we get L equals 5. Which means that my x is equal to 5, because x was represented by my L. Now, the last one, the x value, that's across from the 45-degree angle, so that's an L side. And the 18 is the hypotenuse, which is the L square root of 2 side. This side down here is also L, they just don't have an x there. So this one is similar to what we did on the other side with the 30, 60, 90 triangles, where we had to divide by a square root and then we had to simplify the radical. So we're having L square root of 2, and we're setting that equal to 18. Okay, so I'm going to scroll back up for a second. This is similar to what we did here. We had s square root of 3 equal to 12, and we had to get rid of the radical by dividing it on both sides to get s by itself. So for here, I'm trying to get L by itself, because that's going to give me that missing side. So I'm going to divide both sides by the square root of 2. So that leaves me with this. L equals 18 over the square root of 2. But you can't leave it like that. You can't leave radicals in the denominator. You have to get rid of them. So what do I need to multiply by on the top and on the bottom? Good, the square root of 2. Okay, so across the top, I'm going to go ahead and just stick those pieces together. So it says 18 and the square root of 2. On the bottom here, the square root of 2 times the square root of 2 would be the square root of 4. What is the square root of 4? 2. So it's really a 2 on the bottom. Can you take 18 divided by 2? Yes, you get 9. And then you still have square root of 2. That's your L value. And so that's going to be what the x is equal to.